Okay, this is 3.4 in your textbook, page 164. We're talking about equivalent linear relations. So we are getting into a little bit more type of style questions that you were seeing on the Khan Academy exercise. So I'm hoping, again, I mentioned this at the end of this week, you'll have until to complete the Khan. So I'm hoping that after today's lesson in particular, you'll have a much better idea of how to figure out that Khan with graphing. So let's see. The goal is to represent a linear relation in different forms or different forms. So we're looking at different styles of writing the equation of a line, which we know the proper way we like to write it, or we like to see it, is y equals mx plus b, where m is our slope, okay, and b is our y-intercept. This is how we always like to see it. But we will, on occasion, get different forms of that. Okay, and one way you can deal with it is to just rearrange it into this format, so you can easily see the slope. Or you can also just make a table of values and graph it the way that it is. Okay, so let's talk about that. So the first question on 164, can I have a volunteer to read? Health food store. All right, Michael.
A health food store is making a mix of nuts and raisins. Nuts are $30 a kilogram and raisins are $10 a kilogram. The total mix should cost $150. 30N plus 10R equals 150 describes the relation between the mass of the nuts N and the mass of the raisins R. That's the cost is $150.
Okay, so they give you this formula, all right? That's good news. We like it when we're given numbers and formulas because we know that they're correct and we know we can work with them. So they're telling us that the nuts cost $30 per kilogram. That's why we have $30 times however many kilograms of nuts there are. Okay, it's important you understand how they developed this formula. The other part of it is that we know that raisins are $10 per kilogram. Let's use capital R just so we don't get confused here. Okay, so capital R is raisins. So we have $10 per kilogram of raisins, R representing the number of kilograms of raisins. Okay, and finally we have $150. The total needs to add up to be $150. Okay, so there's several ways that we can graph this. One way is that we can create just a table of values. Okay? So that's the first way we're going to look at, is to graph by table. A table of values. Okay? So the way we do that is we have to first initially choose the independent values. So I could have said raisins were independent or nuts are independent. It doesn't matter in this particular case. It's one of the rare scenarios where which one you choose and which one you measure is interchangeable, okay, in this case. So we're going to choose the independent values for nuts. We put N first, we'll choose the values for nuts in kilograms. So of course we're just going to choose 1, 2, and 3. Now to find the values, the corresponding values of raisins that we need to purchase in order to make a total of $150, we're going to sub those values of 1, 2, and 3 in for N. Okay, so that's what I'm doing here. So wherever there's N, I'm going to sub in 1. So 30 times 1 plus 10 times R is equal to 150. So now I rearrange this. This 30 comes over to the other side. So 150 minus 30 is 120. And then I divide 120 by 10 to leave me with just R. Okay, so the first value I get for R is 12. Okay. Similarly, I sub in 2 for N, and I end up with R equals 9. And I sub in 3 for N, and I end up with R equals 6. Okay, so we can do our first differences here. The first difference is 3 and 3. Small sample size, but we still do have all first differences as being the same. So we know that this equation here is linear. Okay? So let's go ahead and graph it anyways. So we have 1 and 12, 1 and 12, 2 and 9, and 3 and 6. This is the okay, now would this be a continuous graph? Would we say yes or no? What do you guys think? Discontinuous or continuous? You can tell me what that means, continuous graph. Or continuous relation. Nobody remembers? Just a couple, yeah, Mark?
Where it just goes on forever.
Well, yeah, it goes on forever, but something else between the data points is notable. David?
If you pick any point on the graph, like as long as it's in the line, it'll still make sense.
Right, exactly. So if we pick any point on this line, does it still make sense? Okay? So does 2.2 kilograms of nuts correspond to, let's say, 7.3 kilograms of raisins? The answer would be yes, right? If we were graphing, for instance, number of people per number of houses, as I gave you an example before, it wouldn't be a continuous graph. You couldn't draw this line. You'd have to draw a dashed line. Do you guys remember that? And that's because this is a continuous relation. Okay, it makes sense throughout all the halves and quarters of each value. All right? Okay, so that's one way. We're done. We have our graph. Very nice. Wasn't too hard, wasn't too painful. But there is an easier way. Okay? It's called graphing using the intercepts. Okay, so we're going to use the y-intercept and the x-intercept. You want to move the camera slightly? So when we use the y and the x-intercept, what we do is we just plug in a value of 0 for x, and then to find the y-intercept, and then to find the x-intercept, we plug in a value of 0 for y, and find the corresponding intercepts. In this case, we're dealing with r and n, but the idea is the same. You sub in 0 for n in this case, find out what r is. So one of our intercepts then is 0, 15. Okay? That in this particular case is called the r-intercept. And then likewise, the other scenario, we sub in 0 for r, and we figure out what n is. Okay, so we sub in 0 here, we have 30n equals 150, n is equal to 5. So in this particular case, we have 5, 0. Okay, so there's our two intercepts. So I'm going to graph them out. One's there, and one is here. Now I can draw that continuous graph again. Actually, we wouldn't go below 0 because we wouldn't have negative kilograms. We wouldn't have a negative weight. Okay? So our graph would look like that. And you can see it should correspond very the same as this graph. Okay? Slight margin of error there just based on my scale. But you can see those two graphs are the same. So this one was a little easier. We only had to sub in 2 points. We didn't have to create a table. Okay? You guys understand that? Any questions? No? Yeah, Daniel?
Like over there, wouldn't you have to subtract the 30 by the 10 too? Or from the 10?
Here?
Yeah.
No, because the 10 is multiplied by r, so these are two different terms, so you can't subtract them. Okay, so the 30 has to move away from the r, go to the other side, so it's 150 minus 30 is 120. Okay? Matthew?
What if the formula was like 10 equals 2x or something like that?
10 equals 2x, like that? Okay, how would you graph that? So you want to solve for x by itself, so you're going to divide both sides by 2. So you have 5 is equal to x, right? Okay, now to graph x is equal to 5, 1, 2, 3, 4, 5. That's the graph. It's just a straight line up and down. Okay? Because on this line, x is 5. Any other questions? The eraser? Shinoshi, you want to erase?
Oh.
Alright, let's look at another example. Okay, so it says graph this line. Okay, so there's a couple ways we can do this. One way would be to rearrange this equation into the form y equals mx plus b. And then we would know what our slope was, and we'd know what our y-intercept was. We could draw a graph, put our y-intercept, and then use our slope accordingly to figure out what that graph looks like. Okay? That's quite a bit more difficult than just using the intercepts method. Alright, so let's go ahead and use intercepts. So using intercepts. So when we use intercepts, Nicholas, what do we do?
You do like the plus y and you like put a point down,
Plus y? What do you mean?
or like, or I don't know.
Use, okay, pay attention. Michael?
So you solve for each side.
Yeah, how do I do that? To use intercepts, there's the first step, yeah, Mike?
2 times 2 by 0.
Right, so you're going to sub in 0 for x. Good. So my y-intercept is when x is equal to 0. So I take that value, okay, Nicholas, and plug it in for x. So I have 2 times 0 plus 3 over 4 y equals 21. Okay? Now 2 times 0 is 0, so this is gone. So I have 3 over 4 y is equal to 21. Good?
So if there's 3 over 4, do you like solve it equal to 0.75?
You could, but it's easier to just keep it in fraction form, and we'll work with it, okay? So we have, let me show you how to do this. So 3 over 4 y is equal to 21. I want to find out y by itself. I want to isolate y. Okay, so in order to do that, I have to times both sides by 4. Okay, that allows me to cross this 4 out. So I end up with 3y is equal to 84. Now I want to get y by itself, so I divide both sides by 3. So I end up with y is equal to 28. Okay? So what's the first point that I'm going to put on this graph?
28.
The first point, what is it?
20.
Hands up. Jesse. 0.28. Very good. 0.28. That's my first intercept. So I'm going to count up 28. And then I'm going to put the point there. Okay, let's see. This is 0.28. Okay, now I need to find out what my x-intercept is going to be. So in order to do that, I sub in 0 for y. So here's my x-intercept now. My x-intercept, so y is equal to 0. Right, where does it cross the x-axis? Well, it crosses when y is 0. So I sub in y is 0 here. Okay, that gives me 2x is equal to 21. X is going to be equal to 10.5. Okay, so what's my second point, Michael? What's my second point? That's my first one. 0 was the second point. It's on the x-axis. 10.5, what? You're right. 10.5 is one of the coordinates. What's the other? What's the other coordinate, Michael? Try and stay with us, okay? It's not hard. It's not your question, Mark.
0.
Yeah, it's 0. It's on the x-axis, okay? So the y is not nothing, okay? So you're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and a half, and draw your line. Okay? Yep,
Sir, the question is on bond.
yep.
Does that method work for every question or only some?
It works for every method, yeah. The only thing with con is that you have to just drag it to those 2 points, that's all. Yeah, you can use the intercept method on con, yeah.
For the first, when you get the y intercept,
Yeah.
you cross out the fours.
Sorry?
Now you cross out those fours. Like,
This one?
yeah, now you cross out.
Oh, here, the 4s, yeah.
If the denominator is 5, you just multiply it by 5.
Yes. Yeah, both sides by 5. Okay, we're gonna continue after lunch.
Sir,